Basically, the decimal point acts as a separator. It separates the number places that are used for counting whole values, which are on the left side of the decimal point, from the number places that are used to count fractional values, which are on the right side of the decimal point. And that's why you don't see a decimal point in every number. If there's no decimal digits in a number, like in the whole number 25, then you don't need to show the decimal point. It's safe to assume that the digit farthest to the right is in the ones place. Of course, you could still show the decimal point if you wanted to, since it's always immediately to the right of the ones place. But if there's no decimal digits, then we don't need to separate them from the whole number digits. If a number does have decimal digits, then we call it a decimal number. And the decimal point helps us quickly recognize which digit is in the ones place. For example, if you see a sequence of digits like this, 1, 2, 6, 0.53, you can tell right away that the digit 6 is in the ones place because it's immediately to the left of the decimal point. That means this 2 is in the tens place, and this 1 is in the hundreds place. Okay, but what about the digits that are to the right of the decimal point? We know that they must be in decimal number places, but what are the names of those decimal number places, and what values do they count? Well, looking back at our number place pattern, we see that each time we move to the left, the new number place counts amounts that are 10 times bigger than the previous place. So, each time we move to the right, that place should count amounts that are 10 times smaller than the previous place. Since the ones place counts by ones, the number place to the right of it should count by amounts that are 10 times smaller than 1. The amount that's 10 times smaller than 1 is called a tenth. It's the amount you get if you take one whole, like one whole apple, and divide it into 10 equal parts, keeping just one of them. 1/10 is what we call a fraction, and fractions are written using a special notation that has two numbers with a line between them. The number on the bottom tells how many equal parts a whole amount is divided into, and the top number tells you how many of those parts you have. So the fraction 1/10 is written like this, 1/10. Getting back to our apple counting example, previously we could only count whole apples. But now that we have a number place for counting tenths, we can count tenths of apples too. We can use the ones place and the tenths place together to count amounts that are in between a whole number of apples. To see how it works, let's start our counting with one whole apple and no tenths. That means that there will be a 1 in the ones place and a 0 in the tenths place. But now, let's start adding tenths to that. For each tenth that we count, we increase the digit in the tenths place by 1. 1/10, 2/10, 3/10, 4, 5. Let's pause for a second to notice something important. Do you see that having 5/10 of an apple is the same as having 1/2 of an apple? That's because 5 is exactly half of 10, and the fraction 5/10 can be simplified to 1/2. That's why having 1.5 apples is the same as having 1.5 apples. Pretty cool, huh? Anyway, back to counting. 6/10, 7, 8, and 9/10. Now we have one whole apple and also 9/10 of an apple. But our tenths place is maxed out with the digit 9. That's as high as it can count. So what do you think will happen if we add one more tenth? Yep, those 10 tenths combine to form one whole apple, and that will cause our ones place digit to increase to a 2. We now have 2 whole apples. Even though one is made up from slices, the amount is still equal to one whole. See how decimal digits help us count in between whole amounts? But wait, there's more. More decimal number places, that is. The tenths place allows us to count in between the ones. But what if we want to count amounts that are in between the tenths? The decimal number places keep on going to the right, and each time they count amounts that are 10 times smaller than the previous amount. So, if the tenths place counts fractions that are a tenth of 1, then the next number place over will count amounts that are 1/10 of a tenth. 1/10 of a tenth is called 1/100th, and it's the fraction you get if you take a tenth and then divide it into 10 equal parts. It's a very small fraction, and it's called a hundredth because it's the same fraction you'd get if you take a whole and divide it up into 100 parts. So its fraction form looks like this, 1/100. Just like tenths could be used to represent amounts that are in between the ones, hundredths can be used to represent amounts that are in between tenths. And just like if you combine 10 tenths, they equal 1. If you combine 10 hundredths, they equal a tenth. And the decimal number places keep on going like that. The next number place over represents fractions that are 1/10 of 100th. That very small fraction is called 1,000th because it would take 1,000 of them to make one whole. And the next place over is 10 times smaller than that. It's called the 10,000th place. And then there's the 100,000th place. There's the millionth place, and so on. So do you see how truly amazing our number system is? It can represent any whole number amount, no matter how big, by adding bigger and bigger number places to the left. But it can also represent amounts in between those whole amounts, with more and more precision down to the tiniest fraction imaginable by adding more and more decimal number places to the right. A digit's value is determined by the place that it's in. So if a 2 is in the tenths place, it stands for 2/10, which can be written with the fraction 2 over 10. If a 3 is in the tenths place, that stands for 3/10, or 3 over 10. If a 4 is in the tenths place, that stands for 4/10, or 4 over 10, and so on. And just like a 2 in the tenths place stands for the place value 2/10, a 2 in the hundredths place stands for the place value 2/100, and a 2 in the thousandths place stands for the place value 2/1000.